Hey everyone, this is Kyle with Coding on Chain. In today's stream, me and Roberto dive into verifying signed messages with a public key where both the message and the public key are stored in metadata on the Cardano blockchain. If you like this type of content, please subscribe, like, shoot us a comment, and if you're an ADA holder, please check out both our stake pools, Lift and Peace. Anyway, let's jump in. All right, so this is the first Coding on Chain live stream. We have a loose agenda. So I think we're first going to dive into the meta builder, or not meta builder, the meta handler. And then if we have time, we'll jump over to do some Lyft wallet dev, jump in, maybe update how we do the calculation fees, because it's not ideal right now, right? It's like, it doesn't really respond like when you change stuff. So we'll just kind of make it a manual, I'm thinking, like a manual button. Because like if you're just constantly changing, like specifically the metadata, right? That's really what's going to impact it a bit. So, all right. So let's just kind of jump into it, I think. All right. So I need my VS Code. All right. All right, cool. So I think the best way to do this is, all right. So I think you're gonna send me an invite, right, for VS Code. Okay,
Yeah.
cool.
I have your contact here, so I have a magic button that says invite contact. That's right.
Beautiful.
Yep. So let me do this here. And we should be sharing the terminal. Yeah. Okay, cool. So let's try to start from the beginning. What I was trying to do with this meta handler here is to have a uniform way to access metadata. Like we have HTTP URLs. I try to mimic some Cardano URLs that we already have for payment URLs on Yoroi, for ongoing plans to share stake pool links. Yeah, they look like web plus Cardano because browsers have some special handling for web links, so you don't have to. I don't know. It's some kind of standard. I need to look into that deeper, but for the moment, since this is just a proof of concept, I just put metadata plus Cardano, which is pretty descriptive.
Yeah.
Yeah, so basically in Cardano, you have the ability to attach JSON objects to transactions. And these JSON objects have a minimum requirement, that is that the top level object must be a key with following an unsigned integer. So for my test, I decided to use this long one, which is the representation. Just in case you wonder, this is the representation, decimal representation for HTTP. Yeah, so I built this URL, which is basically the protocol, metadata Cardano. This is the authority, which in our case is the transaction ID we want to get metadata from. I added network as parameter, which in our case will be testnet because it's free. And this is the top level key for the JSON object I mentioned. And this is a special parameter that I just wanted to play with, which is to explain that I'm embedding some kind of HTTP response on this JSON object, on this key. Yeah, I had some problems with JavaScript. I'm a system administrator, DevOps guy, which is not very familiar to JavaScript and hate it a bit.
That's
But
fair.
I chose I chose JavaScript because it's widespread. It's I mean, if you want people to actually use a library or whatever, or to start contributing or hacking or just using, you will probably want to write something on JavaScript. So I wrote this very minimum library, which is
So in the library, it just knows how to read the metadata from your endpoint, right? Essentially.
yeah, it will use a GraphQL endpoint, which is also part of the parameters you can add to this URL, and it will default to our Dandelion link deployment, which is ready to go for whoever wants to build on top of Cardano. Just for convenience, I added this as default because this is a proof of concept library and it feels okay to do that. You don't want libraries actually to embed in endpoints or something like that. That's something that you will add as configuration. But just for the convenience of the proof of concept, I added this default.
Yeah, 100%. So
I don't know if you want to go with me.
yeah,
To
so
walk.
let's first look at like what one of these responses is. I think being able to kind of see what we're working with always helps, right? All right, so real
Okay.
quick, I'm gonna drag. So we're using VS Code Live Share. So really, we're looking at Roberto's code. He's kind of this is on his machine. So can you just drag your terminal window up? I think this will solve my problem.
Yeah. If I clear here, if I clear here, oh, it's like watching yourself on repeat with a bit of lag
Yeah.
idiotizes me.
Yeah,
Okay.
it's definitely different. All right, so let's just kind of do what we did, where we just throw a endpoint at it, and then we can just look at because ultimately it's nothing more than headers and then like compressed data. Essentially, it's not like
Yeah.
really that readable, and that's where the library really comes in play.
Yeah. Let's explore this transaction, which I'm not sure at this moment what really contains, but we can go and decode it. So for that, we will execute this script with the URL, which will be processed as argument. Let's see what we get.
All right, so I'm gonna do my best here.
Okay. Okay, I can scroll and you.
Yeah, I gotta scroll on my side. Um,
Okay. So this is
so
the raw content of the transaction for the key I mentioned before, because we could have different keys on this transaction. I mean, we could have this long integer key, but also add another JSON object on key number 1, number 2, whatever. And this is how that key looks like in raw. As I said, I tried to do a weird experiment, which is to encapsulate an HTTP response. For that, basically, an HTTP response is a bunch of headers describing what the response carries on, and the response data itself. As you see, if you can scroll down a bit
yeah, so the
in the
response
terminal.
yeah, so the response has
the-
this. like just base 64 encoded 64-bit like length, chopping up the response, right? So and to note, I just want to be clear, the metadata value here is actually the whole thing. It's, you know, headers with the 3 elements and then the response with the data array. So right, it's not just what's in data. It's literally the whole, like this is an actual HTTP response like object here.
Under that key, because the metadata for that transaction ID could hold different JSON objects on different keys. But for this key, that's
Exactly.
how it looks like, which is not very useful because, as you can see, it's a base 64, which at the same time I needed to split on different strings and concatenate them into an array, because we have some limitations on metadata on Cardano, which is to prevent people like me bloating the chain,
right?
Injecting data that you know, this is not for embedding images or whatever.
Yeah, exactly.
So we have 64 bytes as limit for each JSON key, for the value of each JSON key, and that's why it's a split on this basis. 64 is split on different strings on an array. So if we want to, well, as we saw before, the content type is application PGP signature. We see the MIME type for a PGP signed message.
Exactly. Okay. So, all right. So now I think like we can go ahead and just jump in, right? So, I guess describe the problem right now that you're having and how can we, like, what do we need to do to solve it? Or like, I guess, what do I need to do to help you solve this thing?
Okay. So I was trying to use this script. That's it. And I was trying to get a public key, which is my public key, which is embedded in this transaction, and then validate this metadata. I mean, this transaction contains oh, can you hear me?
Yeah, I got you.
Oh, I lost the Twitch stream, so I guess I don't have enough bandwidth. So I'm trying to get my public key from this transaction, and the response itself is signed with my private key. So I wanted to check that that public key, it's actually signed, that transaction is actually signed with the private key corresponding to the public key embedded on the response. And then from that point, I could use that public key to verify any content that is posted on chain from that identity, which is me. And for that, I have another JSON object on this transaction, which I wanted to verify with this public key. So
okay, so
this is not. Yeah.
All right, I'm gonna kind of reiterate just so I understand like what we're trying to solve here. So you have your public key, right? So this represents basically you, like who signed the message. Mm-hmm. The first metadata protocol, you know, endpoint. That's the actual message that is signed, right? Okay. Mm-hmm. So we want to. So I think the first thing we really want to do is actually parse, right? Can we like, if we can take your public key, right, and we want to parse the HTTP response. That way we know, like, for instance, we have the string. I think that'd be really interesting to display or demonstrate is, here is this, you know, base 64 encoded response that, like, you know, that we just saw that has no meaning to us whatsoever, right? Like, we can't read any of this stuff down here. It's gibberish. So let's.
Oh,
So I'd
I
say
was
like.
using the
Go ahead.
Yeah, I was using the get plain metadata, which doesn't parse any base 64 inside the transaction, because as you can see here or in the terminal, it's lacking the type equals HTTP response. So the library didn't decode the base 64. But we also have this one, for example, which includes the HTTP response, and we could use to check what's on the public key from the other script, on the public key URL from the other script.
Okay, so we just have to pass a parameter, which will go ahead and decode it for us. That way we can actually see what we're supposed to be.
So if you can expand the terminal on your side so people can see.
I can't make it any bigger. I don't. It's this like openness doesn't. That's why I didn't know if like if you pull it up, it makes it different.
I did, but it seems.
Okay.
Okay. So let me save this one and let me execute. Well, we don't have the argument parsing here, so I will just. Oh, that's good. Let me clear.
There we go.
Okay, so this is the get response metadata. Okay.
Okay. Awesome. There we go.
We have a signed message inside that transaction. This is the base 64 decoded. We can see here we have some fingerprint, and then the public key itself. It's a JSON file signed. This is the signature. And now we would like to decode this so it's a bit more human readable. So we could just extract the JSON file. For that, we have this function, which will get the public key URL decoded. This is a bit tricky. I use the OpenPGP verify, even though I cannot verify the message because I don't have the public key from the metadata extracted. So I'm using that to actually extract the public key PGP, and then I can execute this one again and verify what's signed. I don't know if that was.
No, it's all good. I don't. Yeah, it's. All right, so I would say go ahead and I guess like present the problem. Like go ahead and like I'm assuming that you can execute this, and then we get like some type of error, and then we can just do developer things and debug.
Okay. So this will just save the public key on this temporary file. I think that really worked. It's verify rep system data. So I should have no. You see, this is when my JavaScript skills start to drift.
Undefined. Okay, so
that's it.
All right. Proof. All right, so proof. Okay, the first thing I would say is I'm going to just move this for a second. Proof. All right, let's just see what proof is, and in fact, we may have to be a little more specific about that. It might just say like object. Oh no, okay, it looks good. All right, so we actually have, okay, so data.
That's what I
Okay,
what I
so
meant.
yeah. All right, well, okay, here we go. What I'm gonna do now is JSON parse dot data. Let's just see what that does. All right, we're gonna one step at a time. We're gonna get there. Oh, yeah, go ahead next. I think so. Even better. See, that's when you get problems.
The actual problem is how could we save all that? I mean, this resolves the promise, and it's good, but why it doesn't here? So I can. I don't save.
Yeah. So real quick, the fact is that proof.data, right? That's a string. So if we look at the way it gives it to us, it's just a string, and you can't access the string. You can't access a property in the string. So we first have to convert the string to JSON, and then you can convert. Then you can access ID. That's the problem. So it's like right now, instead of
it's working.
That's working.
I mean, if we cat TMP undefined because it didn't resolve the proof data ID. No, it didn't. Okay.
Yeah. Okay. I was just saying, man, that's some magic. All right, let's figure this out.
It did at some point yesterday on some proofs.
That's what you're saying. Let's see. JSON parse. Here. All right, so this is like the research side of things. All right. I mean, ultimately, what we need to do is this, because that's what you have. Like, and we're just trying to do that. But it's saying that there's a problem with your JSON. So what I'm going to do is I'm going to take your JSON.
It's probably because of some character embed on the data. Some escaping problem.
Gotcha. All right, so one thing we can do. All right, so there's on line 2. See, it's almost like, oh, you know what the thing is? I bet you if I do this, it's gonna. Because the way I see it is it's already kind of in JSON. It's just we have all these. All right, real quick. Problem is I don't know what line 123 is, right? Because it's just massive. So what we can do. All right, real quick. Let's just make it pretty for a second. I don't know if this is gonna work. All right, so there's a bunch of invalid stuff. Yeah, it's just complaining about. All right. Do this again. Oh wait, don't do that. Okay. Let's make it go around. All right. Base. Okay, so there's a comma. Oh. ID. Oh, we're missing a comma. So in the HTTP, it's right here, yeah. And basically, like for instance, that comma wasn't there. So it was just invalid to begin with.
Boom. So let's put another object that it's valid. Oh man. I do have it here, and indeed.
Oh yeah, right there. Yep. Well, no, that line has a comma. It's your context. It's at the top there.
It was
Yeah.
this one.
Yeah.
This one.
Oh, okay. Never mind. It was probably just the terminal. Like I saw a comment being entered somewhere that it actually is not being entered.
Okay. So now we need to build again the sign. This is pretty cool because I need to go through the process with you so you can see what I actually did. This is the plain object, which includes my PGP public key, but it's not signed. And then what I do, I'm not sure. Let me. Okay, this is a container with my Keybase account configured. And I used this one to sign that JSON LD file. And then that's the object I put on chain. Let me grab the command from a different terminal. Yep, the out file. So that's actually what we will put on chain. How we include that on a valid JSON file, it's through the, yeah, like this. With this function, I pass a file as argument, and then it builds the object. It does the parsing of the file and chunks it the base 64. Yeah,
So
basically.
So basically, it just converts it into the correct like HTTP response, base 64 cut. You are basically doing a bunch of data scrubbing, and you're cleaning up how it gets put into the chain, essentially.
Yeah. So basically, we had this JSON LD file, which we encode, which we signed with my PGP, and it looked like this. And now we are chunking it on, we are encoding it on base 64 and chunking it so we can send it to the chain. And for that, I can hit the container now. I can, oh man, I'm so used to the terminal that forgot that we are using.
Oh yeah, yeah. I feel like I got one of your hands tied behind your back now.
That was.
So
This PGP. Okay. We will throw it to TMP. Let's call it again public key JSON LD metadata object, which I will send through Leaf wallet.
Nice.
That's it.
Okay.
It built the object and wrap it on this key, which is the one we are using.
All right. So what you just did was you took your PGP public key and we converted it into an HTTP response but it's in the format of a Cardano metadata format, or basically that it's valid metadata. Okay. So PGP
It's
to
now
valid Cardano metadata that's in a HTTP response format that we're going to throw on chain, and then we're going to pull it down, use it to validate a message or verify a message.
okay.
All right. So I'm just gonna keep painting the picture as we go.
Yeah, we could have signed an image, we could have signed whatever, but we decided to sign this JSON LD file containing my public key and encapsulated it on HTTP, and then send it to the chain. Let me do it with Leaf Wallet. I can't share that because it will be tricky for our pitch setup. Okay, so I'm sending one ADA to myself and attaching
Here, real quick. Do you want to here, just go ahead and share your screen. I'll just ruin the live stream here. So we can actually just show the Lyft wallet kind of in action.
Okay, let me try. Okay.
I'm just gonna keep the aspect so when we come back it'll be okay. All right, so basically you have your test address in there. I'll just kind of iterate what's going on there because it's a little grainy, but saying one ADA to himself, and all he did was attach, right there, that meta file. Yeah. Oh, there we go. There we go. It's looking a little better. Yeah, I have his screen cropped, so we can't see everything.
But let's try sending.
Super simple. All right.
I'm not using latest version, so we still have this.
Oh yeah. All right, cool.
Okay, here it is. And this is the transaction ID that now contains a valid JSON file, which we can actually parse. Let's go back to VS Code. Let's do the same thing we did, which is actually just parse this new transaction. And now we can see that it actually includes this missing comma.
Yay! Yeah, it's right here. Right here. I found it. Oh wait, okay, hold on 1 second. Just hide that. It's right here. All right, so now we have, okay. So now when we execute the script, what we want to do, how about this? How about we just try to output the ID value? That way we can just see like, okay, we're parsing the data correctly.
Okay.
All right, so do that. Okay, that should work. I should do it right there. All right, I saved the file. I think you're gonna actually the one have to actually execute because I don't have that type of path. Yay! Okay. Look at that. That's awesome. Yeah. All right, so we just pulled down metadata from the chain. basically it's an HTTP response, right? Because you are using Axios to consume this, right, on some level. Or
yeah,
okay,
it actually, this get function, it's actually a mocked Axios response. So if you actually print public key armor, let's just do it. If we go like this,
oh yeah, okay,
this
that
is
is
this is something that will feel friendly for most developers, and it obviously the chain won't tell you, okay, this is a 200 response, but I do some parsing on the response, and if it doesn't include headers, I consider that the HTTP response on the metadata is corrupt, and I return a 500. If the response data it's empty, I return 204 as a status code. That's the
we can
the
change that to like a 204, right, for like a no content basically.
yeah.
But we can jump into that another time
It's
maybe.
yeah, it's basically like this. I do some
Uh,
some parsing. I say 500 or
oh no,
200
you got
or
it. Yeah, no, you are doing a 204. Look at that. Yeah, nice. Okay, cool. All right, so we now are parsing the data correctly. So okay, what do we need to do next?
okay. So we could, now that we managed to get the
Just so we have it.
cool.
All right.
So right, this object, this HTTP response is signed, and it should match the public key we just have got here. So we could verify that the HTTP response here is valid for that public key, so we can trust that, let's say, publishment on the chain. And for that, I have this other
That's what the first.
function.
Okay, so get and verify metadata. Okay. So real quick, the can you scroll up, or I can scroll up? What am I talking about? So Cardano Metadata Yuri. This is an actual message that is signed, right?
It
Okay.
could be this one,
But ultimately, it's anything, right? Like it doesn't really matter what it is, but we're just saying that particular transaction has metadata that you signed with your public key. Okay, so I'm just trying to paint a picture. So we have one transaction that has a signed message. Again, it can be what the message is almost irrelevant. It doesn't matter, but it's just a message that has been signed. The second transaction we have right here, this is just you saying like, hey, here's like my public key. You know, you can grab it anytime you want to verify things that I sign. Right? This is like publicly available. Just like, please take it if you need to verify that I signed something. Okay. So now that we have your public key off the chain, we can now take the other message, grab it off the chain, and then verify that you did in fact sign that message. So everything is on chain, right? Everything is on chain. This is not like, hey, go to my Keybase and grab my public key. It's
not,
no, go to my
it's
transaction.
not actually, that
Oh,
was, oh, you are not following with me. Yeah, good.
yeah, I am.
So this was the first approach, which is, okay, you have my public keys on Keybase, centralized server, go grab it and then validate this transaction that came from me. This is the next iteration is, okay, grab the public key from chain, actually verify that transaction was signed with the private key for that public key, and then from that point on in time, you can save it on disk or wherever, and you are autonomous. You don't
Oh
need
man,
keys.
that's awesome. All right, I love it. I love it. This is great. Okay, so let's okay, real quick. All right, so let's go ahead and sorry, I'm just going to re-enable this stuff. So what we're doing here is we want to do that. Oh wait, yeah. Okay, so we're gonna save a file with the the name, the ID, right? And then you want to take the public key GPG. Is that right? Okay.
Mm-hmm.
All right, and then we're okay. That's part of the JSON, which real quick.
Yep.
Hold on, I think I have it up. I can just quickly swap. So that's this. So we're going to save. So this is the name of the file, and then we're going to save your public key block, essentially, to the file. Super. Okay, cool. That should be pretty straightforward. All right, great. Just making sure. All right, well, do you still want to output this? Here, what we can do. Here, we'll do a slightly different. We'll do a read stink, just a path. So that would give us a buffer. Let's string that. All right, I'm just gonna kind of leave out some of these.
Cool.
All right. So we should be able to save it to a file, and then we're gonna read that file and then print out the contents of that file. Make sure that we did save the public key properly.
Yeah, let's see.
Cool. There it is. Yeah. All right.
So this is exactly what you will get if you curl this. Just
so we'll do a little just string compare here.
can you span that bit?
All right, so I have your public key here, and what I'm going to do is I'm going to take
Okay.
which file is here. Okay, so I'm going to take this.
It's not exactly the same because I stripped the comment and version from Keybase.
All right, so you took off like the that's fine. I'll do the same just to verify. I think we got with a little difference I can see so far, but I think it's
no, but you got the my personal ID, and we are getting from the chain.
Okay, 1 second. So I'm on the wrong one. Is that what you're saying?
This one. Yep.
All right. Well, that'll do it. That'll definitely. No, I don't want to clear it off. What are you doing? Ah, here we go. Perfect match. Okay. Just a little. Again, just keeping that that picture real clear. Hopefully, of what we're doing here. So, like, cool. even this, like, what we're specifically doing here, this can get a little hairy. This is almost a little even lower than just like, oh, let's just program a wallet, right? This is all right. Let's let's do some private public key stuff to make sure we can we're signing stuff and then you can verify. So definitely, I think we're into the thick of it. But all right, so basically all we did was we took that public key and we put it on chain. We're gonna now verify a message signed with your private key. Yeah,
we will try to verify firstly the HTTP response where this public key came from. But are you following me on the VS Code?
I don't know. Hold on.
No. Ah, right.
There we go. I'm with you now.
Okay. So this is another stupid challenge I need to solve. How I can get the public key file path from this function, because it's an async function and you cannot call, you cannot await for it from this script, from the main script. So
All right, so this is where you just keep wrapping, basically. All right, this is why I'm here. I'm going to show you how to be super good at JavaScript.
I have some surprises for you.
And then basically, that's all you need to do. I assume this has some, you know, I'm going to get there eventually. Okay. There you go. So ultimately, if you need to, you just wrap it, right? You just kind of come up, like create like a main, you know, or an execute function is what I normally do, just for the sake of. You don't have to return anything, by the way. I mean, unless you want to, you can. You can return something if you need to pass something in. By all means.
So this variable will be available just because it will resolve the promise and it's in the same context. Let's say.
We can do that. We can pass the public key back, like the file contents, because that's the public key, right? Do you want? And we could pass that back, and then just pass it into your function if you want, or the file. Basically, just to. All right. So real quick, what do you public key file? Where? Okay. Oh, okay. So ultimately, we do need to pass that in. Okay. Let's do that. But we're gonna return the public key file. Right, so we're gonna call that. There we go. Public URI. All right, so that, and then the Cardano. Where does this come into play? Okay. All right. So do we really want to do this then?
Yeah, I mean, I want to check that the public key inside this URL it actually matches with the signature, and then we can go and check the other object just for fun. I mean,
Yeah.
we don't.
Yeah. No, let's do it.
Even it was signed, we can go there. And let me recheck this function because, well, first of all, we don't need that. Probably is fine, but I'm not sure. Yeah, should be. But let's try and execute it. Aha, this is the surprise I had for you.
Okay. 404. Oh, interesting. Okay.
Yeah, it won't happen if you don't go async and wrap this call. I mean, I think that 404 is for if we just comment this and execute it, it will. It works. So for some reason, when you try again to get this URL with my library, it will fail with a 404. For some reason, the mock for Axios gets messed and it doesn't work.
Gotcha. All right. I'm just gonna dive in. All right. So first thing. Yeah. Okay. I guess I don't really need this anymore here. So what we're going to do just verify. Basically, I think I'm going to have to ask you to execute. I think. Hold on. Yeah, I can't. I don't have control over it. Okay, so go ahead and execute that. Let me see what happens.
Okay.
All right, so okay, so I got your okay. So everything so far is good. At least it looks that way. Yep. Okay.
So
All right. So basically, I just verified the output is what we expected it to be. All right. So now, all right. What is this?
that reads the public file and then uses it.
All right. So I will say that is it's just maybe we got some issues with the fact that this not be.
The problem is that we are again mocking the Axios response here for the exact same metadata URI, and it's not working at that point. I don't know why.
Yep. We'll figure it out. We got it. So we're reading the file. What is this doing exactly? What is? Oh, is this trying to get the file contents just like I just did?
Mm-hmm.
All right. I don't. For the sake of just consistency, I'm going to get rid of that.
Yep.
That. All right. Oh, okay. Okay. I think this is what's going to end up happening. Real quick, let's just kind of. Here, I'm going to get rid of this. Because, like you said, you're doing the same exact call. Like it should work. There should be no issues here. That's kind of like there's something going on. Okay. So let's just do that. So take a. All right. Go ahead and execute that.
And that's probably because I wrote my library with my fits.
Okay, another thing we can do. Okay. Just okay. It is the same. All right, we're going to do a sanity check right here. I wonder if there's something where, like, maybe some cleanup's not happening that should be happening. All right, go ahead and well, hold on. Let me just. All right, yeah. Before we, I'm going to dive into your library in a second. Go ahead and execute that.
Okay. Did you save it? Yeah. So.
All right. So it's
there must
okay.
be some way. I mean, I think it's prototypes being messed on JavaScript, and there must be some way to, let's say, release or remove, refresh, clean up the mock.
Yeah.
The mock object.
All right. So are you following me at this point? Oh no. Okay.
No, but I can see you. And that's the transpiled library, which won't be very readable.
That's all good.
You
Hey,
go for the top.
it happens, man. Don't even like, man. Everyone writes really sloppy code when they're prototyping. If you spend okay,
But,
here we go.
I mean, if you go one directory up and go for the index.js instead of reading this transpiled version.
Oh, I see what you're saying. This one?
No. What's that one?
Oh, you're just talking about. Oh, okay. I'm with you now. I'm with you now.
One level up.
Yep.
One level up.
I'm with you.
That
all
one.
Right.
That's actually what I wrote. So to mock an Axios response, you need to, line 94.
Do you have a util? No. Oh, I see. So line 26. No, that's again not yours. So I'm trying to figure out what call your.
I think the problem is line 94.
Oh, okay, you have it right here. Okay, so mock pack2.
Yeah, because that one, I guess, each time I call the get, it's been like overrode somehow. I mean, you need to make it
Yeah, all right.
variable
So
because
1 second. Hold on. I need to. This is why we research. Okay. Basically, we need to reset. So you're setting up these. Okay.
oh man, that's it.
But I mean, I'm gonna guess because basically, okay, you're setting up these listeners. Is probably what's going on, right?
So maybe right before returning, we can just reset and hopefully 130.
Okay, so how about where do you actually make the call? So it's just this right here.
I guess we will need to do it right after this one
Yeah, let's try.
here because
I'm only afraid that you're going to. Yeah, I mean, go ahead and try that. Go ahead and try that. It's just return response like that's.
that's
I have a feeling
no.
this isn't going to work.
I think I had battle. Transpile. Oh, same.
Yeah. So I think the problem with going putting the mock right here is essentially all right. Axios get you are awaiting. So all right, real quick. 404. That's interesting.
Yeah, that's a weird thing. I think the mock adapter will just get messed in a weird way.
So you've definitely presented a very interesting problem, but it definitely comes down to we got to clean up essentially what's going on. To me, it's this. Is there a way to reset handlers? That's really, you can also reset.
You can restore original adapter. Maybe do all of that. reset reset handlers and restore.
I think oh wait, restore. You can restore the original. Yeah. We can try it, but I don't know if that's going to really be what we want.
I'll let you think while I will just
Yeah,
do what you got to try on the wild. Nope.
I'd say another thing is try to find basically right before, right? Like find the point in the script where it actually is like having that error. So this is like your classic, like hello, 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 like hello 1, hello 2. Then it's just like, oh, right there. Another thing is what you could. Well, I don't know if you can debug since you're. It's no. I mean, you should be able to debug this. I don't really debug in VS Code, especially JavaScript. So.
What about just to it will fail anyway.
All right, let me. I'm just gonna. You know what? Let's just do the hack thing, right? Okay, yeah, that's a lot. One thing you could do real quick. Let's just do this, right? Do we even get there, right? So you're trying to like kind of reset, but there's no like so far we haven't even confirmed that like that's getting even hit. Yeah, and it's not. So that's not where it's failing. Which real quick, we do make one response, right? Like we do make a request, and we make another request. So we should at least see hello guys at least one time.
Oh wait, wait, because we didn't transpile after
okay.
those changes.
I was like, what's going on? All right, let's first just see if we can get it. One. Just see if you can get there first. Don't delete it.
Okay.
I mean, let's just confirm. It's always good sanity checks, right? That's fine. High with some spaces.
Yeah. So
all right.
Let me just because I didn't really try it. Let's reset handler. Wasn't this the name? Do you have the documentation handy?
Yep. Reset handlers. Do you have an S on the end? There you go.
Oh, that's a different thing.
Ooh, okay. Oh yeah, so you're just talking about JSON at this point. Okay. So okay, real quick, okay. Let's not just leave the kitchen sink there, right? Let's see what exactly you need to do. Like which one is it? Like, do you really want to just throw the kitchen sink of like reset, restore? Because it could just be a reset restore. You might not have to do the second one, or you might only need to really do the second one. But I think the restore part is probably good.
Yeah, let's try with the restore because I have the feeling that's what we really need. That's it.
All right, cool. So is it just restore or? Okay.
Yep.
Okay, cool.
Okay, right. Now that was out one. Now we can go back to the verify stuff, the funny stuff we were here for.
Jump to you. Okay. Real quick. All right, so where is it actually airing out? Line 17. Okay. Oh. So there's something up here. Let's go ahead and here. Let's do this. Let's do this. All right. So before we have an actual, all right? Can you run
Let's
that?
go step by step.
Yep.
We're almost there. Man, we're almost there.
That should be an Axios, which encodes, encapsulates. Yeah.
Okay, so data. Oh, okay. Data in this particular case is not JSON, so we can't parse it. That's why that's doing that.
That's it. That's actually an armored message. This
Gotcha. But isn't it the same? I thought it was the same URL. If we're passing the same URL, right? Like down here. Oh, okay. Okay. I'm sorry. I am too far along. Give me 1 second. I am too far. I jumped the gun. Okay, I need to stop following. Unfollow. Let's bring this back. Actually, we might be able to just say the whole thing, but we will need to parse, right? So verified. So really, I'm going to call this verified straight. And then we'll say...
Oh, that's not...
Well, because if you look down at save public key, right, we have... Basically, your verified up here is the proof, right? There should be no difference.
Yeah, but the save public key, that's a tricky thing. It won't, proof contains an invalid verification on the save public key because we are not really verifying anything. I just used the OpenPGP verify function to get the message, but without verifying. And here, it's the approach to actually verify things.
So, okay, so do we not need to get the data or basically convert the string to a JSON first, is my saying?
Yeah.
Okay, so we don't actually need to do...
This.
Okay, if not, we got it there. I just assumed we were going to need to do the parsing again. Basically, it's not in the correct format, so let's get it from a string into a JSON object where we can read because if...
Exactly. I'm gonna...
Which we will. We will. It looks like we will. Unless data... Okay. Just do your thing. I think we're there, actually.
Armored message or something like that. Message, metadata, data, blah, 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 blah. Yep, we can bring up the screen for now. Verify data. Yeah, this should... what should happen is that it will print the public, the JSON object where we extracted the public key from, and saying that it's a valid message. And I think it will work like this. Boom.
Yep, document signature validated for key ID. That.
Yeah, this is the short fingerprint for the public key. Just
Gotcha.
in case
Okay.
anyone is wondering.
Okay, so
this is the long one, which is the one you should share because it's more. It's easier. The short one is easier to fake. Say.
Yeah.
This is, for example, what Charles Hoskinson has in his Twitter bio.
You're talking about the PGP fingerprint, correct?
Okay, so now we have verified that the message where the public key was encapsulated was signed by the corresponding private key. And now we can...
So hold on, let me get this correct. You took your public key, you put it in a message, and then you signed that message saying, yes, I am actually putting my public key in this message, and I'm going to put that on the chain. So you're essentially just verifying that you are the one putting your own public key on the chain.
That's it, because you
Yeah.
could do it.
Identity, man. Yeah. This is awesome. Okay. So now we're going to essentially do the same thing, but do it with not the public key message itself, but something else you signed.
Yeah, that's the ultimate funny thing we wanted to show with this full proof of concept, and I can't even remember what was in this proof of existence object, which is a JSON LD file containing references to some other signed proofs and wallet addresses. Okay, we will go.
But we'll be able to see that here, right?
Yeah.
All right.
So let's clean up. We already verified the public key message. Let me clear here. Let's see what we have. Signature could not be verified.
Ooh, look at that. Can't verify that was you.
And this is probably because this one was signed with my other key.
Your personal one, yeah.
Yeah. But I can go and do exactly the same thing we did before and just sign what I wanted to sign.
Do.
Oh, this worked before, right? Here, or I did it on a different. Yeah, it's probably.
I'll say you don't have to run it in this if you don't want to. I mean, essentially, you're running like a child process, so maybe don't do that.
I think Docker is struggling on my computer now.
Yeah, VS Code is actually using. I mean, it's just Electron app.
Oh, there it is. So I have this. Jason. Oh. This is actually the file I wanted to sign and put on chain. So.
Oh, okay, so this is almost like a nice little hub of all your linked nodes, like your linked data pieces.
Yeah, it's a computer readable proof of existence like this one. I don't know if we have curve here. Like this one. It's on the web, where I, in a human way, state that this is my fingerprint. This is my PGP key. You can find it here. You can find it also on Keybase. I'm the owner of La Resistance Twitter account. You can check that it's actually true because this message contains an image with metadata that contains a message signed by the private key. Also, I'm the admin for this account because of the same proof. Yeah, also the owner for this domain because you can find this file with this signature here. Also, I'm the owner of this TLD, which is a top-level domain on Handshake.org, which is a blockchain project, which is pretty cool, where anyone can have a censorship-resistant top-level domain. And yeah, so this is the human readable proof of existence, and the JSON is for computers.
Yeah, so this is awesome. Okay, so go ahead and sign that, get it up on chain, and let's pull it down and verify. Man, this is really cool. I'll admit, at first it was actually really hard for me to fully visualize what was going on, but I think being able to go through the code like this and go through the steps and see it, well, step by step, it really kind of breaks it down, right? We can talk about like, really, this is just a public key that's been signed by the owner on chain, and anybody can grab it at any time. I mean, using your library, but grabbing it, and then we can use it to verify other things that might be on chain or just other messages, essentially, right? You don't have the signed message doesn't actually have to be on chain, but your public key, that you have validated, like, yes, this is my public key. We can grab it down and verify messages that you have signed.
We could have an implementation of this a chat application that could use the chain to send synchronous messages, signed messages. We could be sure that we are talking with the people.
Yeah. That's awesome.
Oh, this is. Oh.
You have 2 O's.
Oh. Oh shit.
You'll get there.
Okay, so this is the signed message. Now we need to build the object with this. I will use B just for convenience. It was with JSON PGP. We will save it for Leaf wallet. Send it with Leaf wallet. Now we have this read metadata object. And now I can use Leaf wallet again.
So handy. It's so handy just to be able to just, upload a file and be done with it.
Indeed. Okay, send. Waiting for the transaction ID.
So we're going to update the Cardano Meta URI transaction ID when you get that.
Yep.
So real quick, I just want to do something a little different here. Right, we can go to Cardano, test and Explorer. All right, so here is the public key that he signed and has on the chain. So this is, the...
Yeah.
I mean, ultimately, this is your public key, just, all encoded. And then we have, once you get the other one, let me know when you've pasted the other one. All right. All right. That looks almost the same. Nope, there we go. All right, there we go. So, and this is the new one. So we're going to use the public key that is in here, and we're going to verify this message. All right. Amazing. I love it.
Yep. Now let's try and verify that it really came from me. So I updated it. Let's execute again the verify.
Oh.
So we might have some issue there. Let me check.
Well, again, we can just start outputting some stuff. So I think one thing is, let's look at what this is to begin with, right? Well, let's, because there's nothing saying that your message is incorrect, right? Here, go ahead and run again. It just might be how we're looking at the data that's going back.
Yep. Oh, right. It's const.
Oh wait, verified has. Oh, wait, it's already been. Oh, my apologies. That's not actually what I wanted to do. Or did you do that? You did that. I'm gonna blame you. Then again, we'll find out later. All right. So really, what I want to do is just see what. Well, yeah. Let's see what signatures looks like.
They just do match. Maybe reading the public key file, it gets messed somehow.
Hold on. Well, I think verified might be here. I think verified's messed up. I'm just guessing. I mean, don't get me wrong. I have no. This is you. All right. So verified looks like that. Wait. So there's an error. Oh, there's an error. Is that what you're seeing? So there's signature, right? Okay. So the first one. All right. I gotta. There's a callback. Message digest did not match. Oh, okay. I see what's going on. So it's really just doing it properly. What we can do is we can look at the contents before. So we spit out the contents and then essentially look at the metadata.
Maybe when you read a file, is this a buffer?
Oh, that's a buffer. Yeah. Do you need it to be a string?
Yeah. I think that's the problem.
Yeah. There you go.
Yep, save it. Oh. Nope.
All right. So hold on a second. Can we compare? Can we compare the? I mean, because your public key should be on the signature, right?
What do you mean?
Hold on. Okay, let's verify this. Sanity check. Let's just make sure it's what we expect it to be, right? All right, go ahead and.
Oh.
All right, that looked correct.
Yeah. Yeah. Let me do a quick check, which is yeah, public key will be so instead of reading the file,
now note this is your personal. That's your personal URL.
And we don't have access here. But just to make sure. Oh man.
You're gonna get it. You're gonna. Oh, there it is.
Just to make sure we are not messing the public key while writing it to a file, I will just try to wait access get this dot data, or it was response data.
Yeah.
It's response data, right?
Yeah.
And can I access it? Right.
That might work. We'll see.
Can I read property? Now I'm confused.
I mean, it does. So verified does look different, right? So it says valid is null.
Yeah.
Okay, so verified. All right.
So it's not the public key. The object was signed. What the heck?
Is the data like? Hmm.
Is this
Yeah.
what I expect to be? I don't know. Oh, let me. Yeah, it's signature, and then the message. So this is the message. This is the public key, and it works like that on this other file, right? But this was coming from this URL. What the heck?
What do we have different? So, but it's not saying that it's not verified. Is that? I mean, I guess it is saying that, but I feel like, I mean, that's just your error saying that. Because like when I look at the verified message, basically before it was saying that the signature, yeah, this is kind of rough. What you breaking over there? Don't break the keyboard. It's okay. We'll figure it out. It sounded like something snapped.
Yep.
All right. PGP
So,
verified,
yes.
clear.
Just to make real quick.
Oh wait, what's the difference here? Wait. 1 second. I see a difference. I see a difference. Real quick. Where do we go? All right, I don't. Oh, you're putting the data right there. Dang it! You just had to do it differently.
Oh, no.
Because I see this. I see this. Public key armor. Okay. All right, so
maybe
all right. All right, let's look. Let's compare it to the bottom, right? Because we know the bottom one's working, right? Save the public key. So now, armored, you are doing this slightly different, right? So I know you have data here, so you're grabbing that, but this right here, the data, is it the same exact thing as what's going to come back here?
It's actually the public key. Plain public key file. I mean the text, the plain text that it's in the file we save. That's what you get when you do get to Keybase. You know, the thing is that I just put this latest transaction here and try to verify directly from Keybase keys, and it should work because this script works as it was, but like that. It also says signature could not be verified. So I'm starting to think that the object inside that transaction has something that makes the OpenPGP exploit.
So wait, put it back to the old. Did you do that? basically.
That works. And
Okay, yeah.
and we already validated this other object, which is the public key itself, but it's not validating this other one, which we just signed with the same keys. So
Did we? So basically, it's not. Here, can you real quick? There was something really interesting because I feel like you're on to something. This armored message. Can you execute that? There's something really interesting about the outcome of this.
So I went
Oh, we're not outputting
a bit
the same
wild.
thing.
Can you see this?
Which part?
In the terminal, I'm highlighting.
I can't see you highlight stuff.
No, the name on the.
Oh, this right here.
On the object is
yeah.
Unicode. Some the same Unicode UTF-8 weird characters I have on Twitter. I try to put them on this object. I think that at some point they get messed, so the signed message and the message included in plain text don't match. So let me re-encode the object, but without those
special characters.
characters.
Yeah, it'll do it.
I love to do weird stuff.
No, this package makes total sense. I mean, very clear.
I need to do editing outside here. Okay, so now it doesn't include those weird characters. And I will be signing that again. With this. And then let's build again the transaction file for Leaf Wallet. Okay, let's try with that one.
All right, so we are basically just recreating a message, but you're fixing the characters so they're not special characters.
Mm-hmm.
Okay. Yeah, we're gonna have to. We'll have to make like another scene so you can just like pull up the Lyft wallet. Which I assume you're using the Lyft wallet because I see like this bright light right in your face. So there's no dark theme on that one yet.
That's the light we are pushing.
Exactly. Yeah. It's a light wallet in many respects. Yeah.
It's going through the blockchain.
Making its way.
Come on.
Can we do it?
There it is. Okay, so let's try with this object. Aha. That's why. What
That was
happened?
it.
That was it.
All right, so we did it then, right? So hold on, we gotta make a cleaner message here, just for the sake of the stream and the video that people. Basically, we gotta be able to see this thing. Let's clean up a lot of these log messages. Don't need that. Hopefully, I'm not deleting stuff that you want to keep. Don't need any of that. All right, so all I really did was just comment out the log of the actual data, so we can have a clear validation. All right, go ahead and execute it one more time. So we are taking a public key that has been verified by the owner of the public key, and that is on chain. That is on the Cardano blockchain in metadata form. We're pulling that down, and then we're going to grab another message that's on a different transaction, different metadata that particular owner signed and put on the chain. And we're pulling that down, and we're just validating transaction number 2 with transaction number 1, right? So it's all on chain.
Right. Can you expand the terminal so it fits?
I can't make it any bigger.
You did it before somehow. Right. Well,
we'll figure it out. We'll get it for later. Next time. All right.
okay, you expanded that. You want to see.
Yeah, I took away like the data itself. But ultimately, we took. I mean, I think that's awesome. I think being able to store your public key on the blockchain, sign a message, right? Put that signed message on the blockchain, and then have a way of taking the two pieces and validating that that person did sign that, right? I mean, and it's all on chain, no centralized, places of storage here. So, I mean, really the next step is getting this in the Lyft wallet then, right?
Indeed. This is like the very, very, very light implementation of decentralized ID, which is just publishing your keys in the same fashion that we usually do on GNU-PG.NET servers or Keybase. You need to tackle a lot of challenges, which is like revocation and stuff like that. But we now have a replacement with this for keybase.io/verify, which is basically can you go to that website?
Yeah.
Actually, we can do some another cool thing.
All right, so where do you want me to go?
Yeah, please.
Where? Keybase.
Keybase.io/verify.
All right. Oh, okay. I got you. Here. Why don't you can pass me what you want me to put in here through VS Code.
Okay. So we could actually verify the same message. The plain message we put on Cardano with Keybase, but wouldn't it be cool to get rid of the Keybase and have this on Lyft wallet so you can
man, yes,
verify on your own?
That's exactly what we're gonna do.
So that's the ultimate thing.
Here, why don't you? So, like, to demonstrate that what we just did, let's see. Can we output the pieces of data that these two endpoints are producing, and that way I can just grab the data off of them, and then just show that, like, we didn't just put out a message that says, yeah, it's been verified.
The easiest way is to use this script. It's be responsive.
All right.
Oh,
it's a little gross, but it's stringify. That's fine.
Yeah. can remove that and it should work.
Try it. I think I added that. All right.
Yeah, so if you copy all that, can you copy that?
Mm-hmm. All right. All right. So that goes in there.
Mm-hmm.
All right. So now we have the message.
That's coming from Cardano, from the URL we showed, and it's you push verify on the bottom. That's it, and it should say that it's from rep systems.
Yep. All right. That's awesome. Is there? I guess we can't. That's awesome. Yeah. That is awesome. Yeah, I can't wait.
I try to represent on this JSON object, JSON LD object, the same that Keybase presents when you visit my ID.
Yeah, this isn't there. What's this right here? Right? No, that. Isn't there like isn't this JSON like actually? It doesn't matter. Ultimately, what we did was we verified that you signed that message, right? So, that's awesome.
So another cool thing that I added to the to the condensed proof of concept is I added some Cardano testnet addresses on that object. So the first one is the one I use to send the metadata to. Not
okay, right here.
So by transacting, attaching metadata signed with these keys from transacting from these addresses, I could prove that I own those addresses.
Oh, okay.
So
yeah.
Cardano wallet will be tied to my PGP. We could build cool things on top of that.
Yeah. No, okay. I see what you're saying now. This is awesome. I mean, I think what we demonstrated here is a great proof of concept, and I think from here we can really actually bring this into Lyft, so people can. I mean, we could even add things along the lines of like create an identity, right? Or like, like basically it's like, okay, let's do what you did first. Let's give you some keys that are associated with a wallet, and we can put your public key on the chain. And then it's like, okay, enter a message, sign that message, select the wallet you want to sign that message with, and then put that on the chain. And then that way you could even go back to where it's like, hey, validate or verify a message, right? So it's like, give me a transaction ID and the public key essentially, and then we can compare, right? Did this public key actually sign that transaction that the metadata that's on that transaction?
Another cool thing is that, do you see those encrypt and decrypt buttons in Keybase webpage? We could use the blockchain to be like an event bus or a messages bus to send encrypted messages in plain, not plain, but in HTTP fashion. That will be another cool proof of concept to do.
Yeah, that's awesome. All right, well, I think we can end it here. I mean, that was success, right? We solved the issue, right? And we actually were able to verify messages that were on the blockchain with public keys that are on the blockchain. But yeah, this is awesome, and hopefully we can have more successful streams. I was a little afraid we weren't going to have a successful stream on the first one. But yeah, well, I think we're going to call it there. I really appreciate anyone who followed. I know James jumped in there and was able to get a little bit of the stream. We'll put it on YouTube so people can look back on this. And this was really exciting, really fun, and hopefully we'll do this a lot more in the future. See you guys.
Yeah. See you. Thank you.